Welcome to APA's weekly webinar series, co-sponsored by the Center for Campus Fire Safety, CCFS. My name is Billy Zadek, Standards and Codes Administrator for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA webpage later this afternoon. You will receive a follow-up email in the next couple of days with a link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through December 2020 and open for registration. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking a question by one of our presenters. Professional continuing education credits, AIACLUs, and ICC recertification credits are being offered. For AIA certificates, please send an email to billie@BILLIE@APA.org with your membership number if you have not done so previously. For ICC CEUs, if you are a CCFS member, please email Kathy at ctaber@campusfiresafety.org for your certificate. At this time, it's my pleasure to turn this over to Kathy Tabor, who will tell you a little about CCFS and introduce our presenter for today. Kathy, take it away.
Thanks, Billy, and thanks everyone for joining us today, and also a big thank you to our presenter, Roger Reiswig. CCFS is a national nonprofit member-based organization dedicated to campus fire safety since our beginnings in 1999. We're governed by a 12-person board of directors, and they're located nationwide. The majority of our board are fire marshals on college campuses, fire safety educators and inspectors, and some of our board members are also well-known international industry leaders. I guess I like to say we're fortunate to have a leadership team made up of well-known and respected leaders in the area of campus fire safety. Our activities include training programs for campus fire and life safety officials and emergency responders, premier events such as the annual Campus Fire Forum and Campus Fire Safety Month activities. Unfortunately, our forum for this year, 2020, is canceled, but we will have it again next year, 2021, in the same place in New Jersey. As a member benefit organization, we offer free webinars, CEUs, discounts for training, online job board, listserv discussions, et cetera, et cetera. So check us out on our website, myccfs.org. At this point now, I want to present our presenter, Roger Reiswig. He is the VP of Industry Relations for Johnson Controls. He's also the Global Industry Liaison for building codes, installation standards, product certification standards, and a representative for various life safety industry associations and organizations. As an example, he is the immediate past president of the Automatic Fire Alarm Association, AFAA. He's on the Center's board of directors, and he sits on several Nfpa committees. Roger is NISET Level 4 Fire Alarm certified and NISET Level 1 for special hazards. He holds a certification from Two Rivers Technologies as a Master in Telecommunications, an Eastern Technical Certification in Electronics Technology and Microprocessor Design. Roger also has a master's degree in theology from the Evangelical Theological Seminary. So at this point, I am going to stop talking and just turn the presentation over to Roger. Roger, I should have sent you a link to the print.
All right, and hopefully you're seeing my screen now, Kathy.
Yes, I can see it. Perfect.
All right, great. Well, thank you. Thank you very much, and thanks for that introduction, and for all of you out there tuning in today. I appreciate that. I worked with the Center for Campus Fire Safety for a very, very long time. I even, back in the days when Bruce Frazier came back to Simplex Time Recorder Company and said about being part of that, and then along with APA and AFAA, I just love to see how the industry works together on a lot of different things, and then as proof of that today for the educational seminar. I'd also like just to make a shout out to a good friend of mine and Dave Newhouse. He helped with some of the content that I'm going to be providing today, and I really appreciate that, and I just wanted to give him credit for that. And if anybody knows Dave, today is his birthday. So let's go ahead and let's jump into this. So let's talk about, I get a lot of questions about UL and the smoke detection changes that have occurred or are occurring, and this Hamburger Test, is there really a Hamburger Test, kind of tongue-in-cheek? Let's just talk about, all of this topic here today. And anybody that has been in any of my seminars in the past, I like to give you a little bit of the background. How did we get to where we are? Because history just didn't start today. So with that, I'd like to just kind of jump in and talk about some of the factors that have been going on in our world that cause the changes to have to occur. Because it's not just the hamburger thing that happened. So there's been a lot of factors that have driven the recent changes in both Nfpa 72, the National Fire Alarm and Signaling Code, as well as the UL Underwriters Laboratory standard changes. We talk a lot in our industry about tenability of an area or a building. How long can I stay inside of a building while an event is going on, fire, smoke, or what have you? And things have changed a lot in our construction industry, our furnishing industry over recent decades. And then there's also that whole discussion about ionization or photoelectric technology, multi-sensor, multi-criteria, and all the rest of that goes with it. And then NFPA 72 kind of got thrown a few jabs a few cycles ago about our plaguing false alarm problems that we have in our industry. So, or was there really a problem? So let's kind of talk about some of these things, and let's dispel maybe some of the myths that are out there, or some of the, and let's put some facts to what's happening. So there's some statistics that are out there that show how smoke detection and fire alarm systems have saved lives over the years. As you can see here, residential fire deaths have decreased. So we had 6,000, a little over 6,000 deaths in 1978, and today, 2017 was the last number I could get. We had 3,400 deaths. So you see the numbers going down. Non-residential fire deaths have also decreased, 640 in 1977 to 105 in 2017. Hotel, motel fire deaths have increased, and there's been different issues with that, but basically it's remained sort of flat though, 62 in 1980 and 80 in 2017. But I think one of the also telling things is the U.S. population has dramatically increased too since 1978. As you see there, 222 million up to, in 2017, 325 million. So if you can remember, or for those of you that were around like me back in the 70s, that's when smoke alarms were introduced and started to be required in our residential home markets. And that has been a huge help, a huge saver to alert people to an event that's going on in their facility, their home, or what have you, and to help them to get alerted and get out. So then we talk about cooking and nuisance alarms. So we have smoke alarms that we put in our house, and let's just hold on for a second. So we have smoke alarms and smoke detectors. And again, because I like to use the right terminology, and we should all be doing that as life safety professionals. So a smoke detector is a device that runs or communicates to a fire alarm control unit. Maybe it could be a Berg intrusion panel that's listed for fire use also, but it's some type of a control unit that is going to be used to indicate or get an alert that a smoke detector has gone into alarm. And then the control unit decides, call the supervising station, fire department, activate horn strobes or what have you. A smoke alarm is a device that has self-contained a power supply, a notification appliance, and a smoke detector. All of those work together. So when we say smoke alarm, we mean a device that has all of that, kind of like that you buy at a big box store, Home Depot, Lowe's, and you buy it, hook it up with a 110-volt AC, 9-volt battery, stick it on the wall or on the ceiling, and away you go. That's a smoke alarm. a detector needs to tie into a control unit. So I just make the differences because sometimes people will call us, even today, and say, hey, my smoke alarm is making noise. Okay, so you're talking about a device that's standalone. No, it's the control panel. Okay, let's make sure we're using the right terms. So with that, let's go back to our story here. So what are the dangers of cooking nuisances? And the problem that has occurred is the number one problem in our homes today is cooking. Cooking overwhelmingly is the majority of our nuisance alarms or unwanted alarms in our residential occupancies, homes, apartment complexes, what have you. As you see here, 73% of all nuisance alarms are caused by cooking. So whether you're burning something or maybe you have certain embers that are not embers, but gases that are being released on certain cooking oils or what have you. And the problem with that is it becomes a cry wolf syndrome, or people become complacent. They think, oh, the smoke alarm went off again. It's just a smoke alarm. Somebody must be cooking. And at worst case, they pull them down, take the batteries out, and we don't want that. And in fires where smoke alarms were present but did not operate, 46% had missing or disconnected batteries because they were going off when we didn't want them to happen. So that's been an issue that's been plaguing us for a while in our industry. So some proposals were submitted to Nfpa 72. Proposals were submitted to say about photoelectric and ionization alarms. And just real quick, for those of you that don't know, photoelectric in its simplest terms, we have typically everybody does it pretty much the same way across the manufacturing line. You have a photoelectric and infrared beam inside a chamber, and it's looking for something to reflect that light, that infrared light, into a photoreceiver, photodiode. And that could be smoke, it could be dirt, it could be pretty much anything that's able to reflect those properties. In contrast to that, we have ionization. Ionization is where we inject a little bit of radioactive material, very, very minute amount, and it's americium, and we compare the conductivity of the chamber based on the radiation that is emitted into that chamber, and when smoke or combustible particles enter that chamber, it disrupts that field. And that's how we monitor to go into alarm for ionization. So that's where people say, hey, I have a smoke alarm on my ceiling. I didn't see any smoke, but a good whiff of stuff came out of the oven that I was burning and my smoke alarm went off. How could that happen? Because those particles that were in the air were combustible, and it affects the chamber of that ionization smoke alarm and caused it to go into alarm. So that's what was happening. So smoke alarms and smoke detectors, the proposal was that they couldn't be installed within 20 feet of a cooking appliance, and they shall be of the photoelectric type. And I have one here that was rejected. Nfpa 72 committee rejected that. And the reason that they rejected it, above several reasons, but the main one was, you will find that Nfpa, ICC, the International Code Council, UL, Underwriters Laboratory, they're not in the business of limiting or restricting technologies. To a point, I know there are some things, but in simple terms, they're not in that business. The business that you see Nfpa in and ICC and UL is, this is what needs to be accomplished. You figure out the best way to make it happen. So rightfully so, this was rejected. Whether you agree with it or not, the principle was it's not up to the Nfpa committee to sunset or cancel or get rid of a technology. It's up to the industry to do that. So another proposal was submitted, and again, we're going back a few years, but here you see smoke alarms and detectors shall be installed within an area of exclusion determined by 10-foot radial distance along a horizontal path from a stationary or fixed cooking appliance. So you had to have a device that was 10 feet away, and here was the trigger for a lot of things that have occurred in the recent decade. Unless listed for installation in close proximity for cooking appliances. So you had to have a smoke alarm or detector that went through some type of a certification process that was now listed to be immune to common cooking odors. And this was kind of the catalyst that got a lot of things happening in our industry. So, and let's just stop also a little bit and remember that building codes like the IBC and Nfpa 101, they tell us when to do something or where to put things. Nfpa 72, for example, is the National Fire Alarm Code. It tells me how to do that. And then the underwriter UL documents tell me how the products need to function in order to meet the requirements set forth in the standard. So I bring this up because I still get calls today with people saying, hey, I'm doing a new building, and where in 72 does it tell me I need a fire alarm? It doesn't. 72 says where required by the building code or other local jurisdiction requirements, this is how you do it. So it's important to understand that one drives the other. So the building code drives the standard helps to drive the listing standard. Not always, but pretty much for the listing standards. So NFPA put this in, and typically, again, not always, what happens in NFPA 72 will drive what's changed in the UL listing documents for the various products, whether it's a control unit, a smoke detector, or what have you. So here, since we had the device, unless it was listed for common cooking odors, then that's what drove the UL to have to do something. I'm trying to kind of formulate the strategy or the timeline of how all this started to occur. So that's when UL said we need to create something different or modify our UL standards or maybe do some more testing to figure this out. So now that it starts to invoke the UL standards people to start to look at how can we make the great products we already have on the market even better. So with that, we have, again, a little bit of history I wanted to kind of bring out. So I know there's a lot of acronyms on here, and I'll try and let you know what's going on. So, and again, the main reason I'm going through all of this with you today is to give you the information that it just wasn't something that happened overnight. UL decided they needed to change, and this Hamburger Test came about, and it put the industry into chaos. There was a lot of rationale and discussion before we even got to where we are today. So if you kind of go through this timeline a little bit, you can see that a lot of work was happening in the background. FPRF is the Fire Protection Research Foundation. They're a wing under the NFPA umbrella. They're a standalone entity under NFPA, and they do a lot of the research, either supervise other entities doing the research or do some themselves, and provide the substantiation to things that we put into the codes. So if you come in and say, hey, smoke detectors should be spaced, I don't think they should be spaced 30 feet, they should be spaced 35 feet. Great, where's your substantiation? Where's the background, the justification to do that? So the Research Foundation helps us with that. So they did a smoke characterization study with UL in 2007. Now the UL 217 is the standard for smoke alarms, UL 268 is for smoke detectors. The same functionality of how a smoke detector needs to operate is pretty much identical in both standards. A few differences here and there, but pretty much they're the same. So STP for UL is the standards technical panel. It's a group, it's a consensus of, or cross-section of the industry. So you have manufacturers, authority having jurisdiction, fire marshals, AHJs, you have insurance people, end users or consumers. So you have a lot of different people that come to the table. It's not just UL doing this in a vacuum. And they did some research in 2008. Consumer Product Safety Commission did a project in 2010 on nuisance alarms associated with cooking. NIST, National Institute of Standards and Technology, along with Consumer Product Safety Commission, did a smoke alarm performance in kitchen fires and nuisance alarm scenarios in 2013. NIST did a justification for new smoldering and flaming test performance criteria 2014. The Research Foundation, again, did a smoke alarm nuisance source characterization in 2014. And then UL did another characterization of smoke alarm nuisance sources from cooking events in 2015. So you can see a lot of different entities were at work over the past 10 years or so to kind of get us where we are today. So a lot of smart people doing a lot of smart things out there. So I hear a lot also about, well, it's the new 8th edition. Well, that's true if you're under UL 217, but UL 268 7th edition. So they're a little bit out of cycle as far as the editions are concerned, but they're pretty much what goes into one almost goes into the other. Now, again, because we talked about a smoke alarm has to have a power supply, has to have a notification appliance embedded inside it, that's why it needs to be a different standard. Because I can't take a fire alarm smoke detector and try to get it listed to UL 217 because it doesn't have a power supply, it doesn't have battery backup built in, it doesn't have a sounder built in. That's why there's two different standards. But again, the performance criteria is pretty much the same. So all of that you just saw earlier, all of that research was kind of combined, and over 215 revisions or additions were added into these documents. new performance tests were put in place for not only smoke alarms, but smoke detectors. And then an effective date is out there. And we need to talk about that too as we go along. So one of the other big things that has been occurring is the construction materials that we utilize today in all aspects of our lives, whether it's business, commercial, or home residential. And polyurethane is used predominantly in what we use in our construction today. And polyurethane is kind of an interesting piece of material on how it smolders, how it flames, its gases, characteristics that it gives off, the color of the smoke that it gives off, dependent upon if it's smoldering or flaming. It's really kind of interesting when you get into that. So there's different sections that were impacted by flaming polyurethane as well as smoldering polyurethane, and I'll talk more about that as we go. And then cooking nuisance smoke tests were also added into our standards, UL 217, 268, for these smoke tests. So where I think a lot of this comes into play in the life safety world, we talk about egress time. How much time do I have to get out of a facility, a house, an environment, and have safe amount of time to get out? So we call that egress time. Now we have available safe egress time and required safe egress time. And what we're looking at is, do I have enough time to be alerted, to get myself together and get out of the facility? And what's happened is the window of time that we have compared to what we used to have has been dramatically diminished. So in 1975, we had 17 minutes of available safe egress time. In 2007, that was shortened to 3 minutes. The average ASET time, available safe egress time, for smoldering fires in 1975 and 2007 tests were similar. So how the tests were conducted. But the flaming part is what is really something that is come into play or impacted us. And it's our furnishings. This polyurethane that we're using today, the synthetic fibers, we're not using natural materials like we used to pre-1970s, if you will. And the combustion characteristics, the behaviors of how these synthetic materials operate, they vary greatly from one to another. And they're used widely. This polyurethane is used widely in our homes, commercial buildings, and polyurethane was then deemed to be used for the new UL test, and it's already being used in other tests. You know, in UL 1636 for residential sprinkler standards, it's used in the EN for Europe for 54.7 for fire detection already. And you start to look at the flaming particle signature, it kind of gets interesting. So the smallest particle tested is approximately 0.05 micrometer. It's black in color, and it's kind of a unique burning characteristic where it burns, it goes from a solid and it transitions to a liquid. And smoldering polyurethane, the particle size is a little bit different yet again, 0.09 micrometer, and now it's a brownish golden color. So my detectors need to be able to pick this up, whether it's flaming or it's smoldering. Now, this is a video, and it's a few minutes, and I'm going to go ahead and start it here, and you'll be able to watch. There's no audio, but this was done by UL, Underwriters Laboratory, so credit to them. It's a comparison of a room of furnishings, and the room on the left is natural room. Think of it with a room that was built in the 1970s. It's got the 1970s style furniture, natural-made construction materials are used, cotton, wood, etc. But on the right, it's a synthetic room. It's materials that are used in today's environment. It's composite, synthetic, polyurethane, particle wood, and things like that. So let me go ahead and start this and watch the timeline as both are started at the same time. And as the fire starts to grow there around the couch area and around the lamp on the right. So you see on the left, we're coming up on a minute. We got the pillow there kind of starting to catch on fire. On the right, we got some smoke giving off, and it starts to get a little bit greater here, coming up on a minute and a half. And now if you look on the minute and a half side, you see there's a lot of smoke. It's starting to come down from the ceiling. And the fire is starting to grow a lot more. A lot of toxic gases are being given off. Look at the fire on the left. Fire on the left, still smoldering. I still have plenty of time to get out of the building. The one on the right, I'm running out of time. My egress time to get out of that room is rapidly diminishing. 3 minutes here, you can see the room is basically untenable. I'm done in that room. I need to get out or I'm going to perish. And there we have flashover starting to occur. The room on the left, here we are coming up on 4 minutes, and you still have time in that room to get awakened, maybe get yourself together, get out of that room, grab a fire extinguisher or whatever you're supposed to do in your area. But look at the time now. We're up to 25 minutes, and then there we are at flashover later on. This is the telling story right here about why smoke detectors, we talk about them saving lives, why they're needed. And yes, we also agree at the Center for Campus Fire Safety and the Automatic Fire Alarm Association, you need both. You need residential sprinklers and you need smoke detection. They work together. Smoke detectors alert you to get you out. Sprinkler systems are there to control the fire until the fire department arrives on scene. So huge, huge difference. Now, in the residential chapter, chapter 29 of NFPA 72, they needed to address this, or they were trying to address this. And they wanted to avoid the nuisance problem because that smoke detectors need to detect smoke quicker, alert you because of these synthetic materials that are in the room. You need to get alerted quicker and get out of the building. But nuisance alarms are still plaguing us with cooking odors or other things, and then people become, again, complacent. So the challenges to us manufacturers, again, I work for Johnson Controls. We manufacture smoke detectors, and this was a challenge to all of us, no matter who you are, because now we have different particle sizes, whether it's flaming or smoldering, whether the color, brown, golden, or black, comes into play. And then I also need to avoid common cooking odors. So the cooking side, so let's talk about that. So we can't just make a device that detects anything and alerts you immediately, because then we might have nuisance alarms that we talk about. So there is a hamburger test. And so why was frozen hamburger used for these new requirements? So as we go into this, the characterizations of the smoke alarm nuisance study that was done determined that it was the best surrogate of all the cooking nuisances. You know, at first there was discussion about, well, we should have you test for pizza, frying vegetables, bagels, bacon, toast, and hamburger. Well, we can't do that. We can't have a device in there for weeks on end trying to get tested for all of these various things. And it was found that, well, if we broil frozen hamburger, it kind of acts across its burning process, it kind of acts like the rest of these items, the pizza, the frying vegetables, bagels, bacon, toast, hamburger. And those are the top things when the study was done of the issues that people were having when they were doing these things. And then broiling frozen hamburger produces a broad range of particle diameters. So small particles initially followed by larger particles, 0.01 micrometer to 0.08. So it kind of starts to fall in that requirement that we have there. And it challenged all of us smoke alarm manufacturers, whether we were doing ionization, photoelectric, or combination. And it's also repeatable results. So the certain type of hamburger frozen for a certain period of time, moved into a certain type of broiler, is how the test is conducted. And just like you see here, it's actually just what you think. It's hamburger that is purchased, frozen, shoved inside a broiler, a time goes off, and we have to alert for that and not go into alarm for the nuisance side of the device. And when I put smoke detectors in a chamber, here's just a couple of snapshots. You know, I put in multiple devices, and they're going to verify the percent of obscuration in the room, the ionization, the MIC devices they call them, to be able to determine what level of obscuration I'm looking at, and before the test and after the test, and how it's a little bit of a haze in there, and timers. And so all of these are requirements that I have to meet within the UL documents. Now, for polyurethane, we have a flaming fire test where they take a cube of polyurethane, and I have to be able to detect it in so many seconds of when the polyurethane catches on fire, starts to flame. And then likewise, there's a smoldering test where they'll put in a heat generator and shove it inside. I don't know if you can see it here in the center of this cube. They shove it inside it and then ignite or energize the heat element, and it causes the polyurethane to smolder, and I got to be able to detect that. So again, different characteristics that needs to come into play. And again, the whole goal behind the UL changes for 268, 217 had to do with giving us the most amount of egress time the alerting of safe egress time that we could, and without causing nuisance alarms or unwanted alarms. We wanted to make sure people were being alerted and can get out of the facility. So there are sensitivity values that come into play. Some of these, this was borrowed from Nfpa 76. Whether it's standard fire detection, early warning fire detection, or very early warning fire detection. And these were just levels that were pulled out, you know, at 2.5%, 1.5% obscuration, and less than 0.5% obscuration. And this has nothing to do with like a VESDA system, if you will. This is the terminology that was pulled out of the telecommunications document. So 2.5% obscuration is something we've pretty much as an industry have gravitated to across all manufacturers. Some might do 2.2, some might do 2.7, but the average has been 2.5%. UL has given us a window over the years of where we needed to be able to have our devices operate, 0.5% obscuration up to 4% obscuration. And the industry has gravitated to the middle of that for our devices. So UL needs to define these requirements on what's our sensitivity range, you know, because that's also going to change. Am I going to be at a low sensitivity, a standard sensitivity, or an early warning sensitivity, or what have you? So there still needs to be some work that's being done on that for our obscuration settings. And then what about performance-based design? Because in performance-based design, we've been able to use this percent of obscuration, run modelers, and say, okay, I have a 25 kilowatt fire, and it's smoldering for so many minutes, how the smoke propagates throughout the rooms, context with beams or partitions in a room, and where the smoke flows, and then having a smoke detector that can detect that 2.5% obscuration. With the changes that are occurring, is this still going to work? And this is a question I still have, and I think others still have in our industry, and it's a learning experience for us. But if you're doing a performance-based design where you're doing these modelers, do the modelers need to change now based on how these smoke detectors now need to function? And then spatial applications, you know, also come into play for telecommunications, clean rooms, things of the like. So this smoke signature, these were the three things that kind of caused the industry to have to do a complete reinvention of their devices. The flaming produces the small particles, black dense smoke, smoldering, brownish gold, heavy to medium to heavy build, a little bit bigger particle size, and then not go into alarm, cooking nuisance resistance. No manufacturer that I know of had a product in the marketplace that was able to meet these new requirements and go to UL and have their device relisted. Pretty much all of us had to go back to the drawing board, create a new product, modify what we already had, or what have you, and that caused us all a lot of potential to create better devices, if you will, in the industry. So the challenges to us, you know, we've always talked about photoelectric or ionization. They just weren't capable of meeting the new requirements, just how they used to work. Smarter detection is required. Some have chosen to use multi-criteria. You know, and when you talk about multi-criteria could be carbon monoxide, a heating sensor. It still could be ionization, could be photoelectric. But we also have multi-sensor out there. In Nfpa 72, both are defined. We have multi-criteria, where it's different types of ways of sampling the environment, and then they work together to figure out, you know, what's going on. And there's multi-sensor that's also out there. But it needed to be cost-effective. You know, when I initially was talking with my R&D engineers in Johnson Controls, they said, Roger, I can tell you whether it's a trash can on fire, a potato burning in the oven, draperies on fire, but their smoke detector is going to cost you $500 to make that happen. And nobody wants a device that's going to be hundreds and hundreds of dollars, you know, per device. So we needed some type of a cost-effective solution. And then narrow the production limits, you know, 5% flaming polyurethane foam limit, 12% smoldering polyurethane limit, and then 1.5% cooking nuisance limit. And all of those needed to come together, and also my compliance date on when I needed to have these devices available. So where does all these revisions leave us? So we have installed units that are out there. There is no requirement in 72 and 101 and IBC and UL that requires you to replace your existing devices. That was never the intent, and that's not the requirement. The devices that are installed are perfectly fine as long as they're functioning properly. They're tested when they need to, And for smoke alarms, they need to be replaced every 10 years. There's a date that needs to be stamped on them on when they were manufactured, not installed, and they need to be replaced. And for smoke detectors, as long as they meet the sensitivity testing every time it's done, initially every other year, and then if it passes every other year, every 5 years for a sensitivity test, and then the functional test where you actually inject smoke into the device to verify that it's functioning. Magnets are not appropriate or effective way of testing a smoke detector. So that if anybody is doing that, that does not meet the code, and actually says that in 72. So if you're doing retrofit of projects, again, it's going to be up to the building owner. If your smoke detectors are there and they're working fine, again, there's not a requirement to replace those. In new construction projects, we have the industry has the newer devices that are available. But for right now, you can install devices that were manufactured by a company from the previous edition of UL or from the new edition of UL. There is a time frame set forth in NFPA and UL of when the devices are mandated. But for new projects, right now, you can use either one you want in our industry. Again, there's not a requirement to replace what you already have. And I've heard that from a few customers, a few people out in our industry. It's just not true. So let's talk about this effective date thing. So UL 217 is a smoke alarm, and it's the 8th edition. UL 268 is the 7th edition. Now, what we say when we talk about the UL document, UL is the repository, the holder for the United States of standards for our life safety world. And they hold the standards, whether it's for toasters, roofing materials, fire alarm, life safety equipment, and on and on and on. And the industry comes together with their standards technical panel and works with UL on creating the documents and updating the revisions or additions as they come out. Then companies, UL is one of those companies, are able to take the UL standard. I know this is getting kind of confusing. You can take the UL standard and get your product certified or listed by several different companies that are out there. In the United States, the companies that are able to do this, we refer to them as nationally recognized testing laboratory. So you might hear people talk about a NRTL and RTL. And in the United States, you don't have to have, and again, I'm not saying anything against UL, right? But please don't take it this way. But UL is not the only game in town. There are competitors who can list product or certify product. Probably one of the second biggest ones out there is ETL, Edison Testing Laboratories. And they take the exact same standard, UL 268, UL 217, and can list product, certify product. So it's up to the company then to decide what their compliance date is going to be. UL has decided that their compliance date was going to be May 29 of 2020. The date just passed here a month or so ago, 2 months ago. And UL decided that they need to extend that date for a few reasons, and they've moved it out now till June 30 of 2021. ETL has said, on the other hand, they said, well, our implementation date, compliance date of when we're going to mandate you to be tested to the 7th edition or 8th edition, respectively, of 268, 217, will be December 31st of 2021. So now we have NFPA 72. NFPA 72 has now said in the 2016 edition and 2019 edition, smoke detectors, smoke alarms used in cooking areas need to be compliant with the new standards by January 1 of 2022. So if we step back for a second, there's a few different dates that are out there. And again, UL is kind of the biggest that's out there. It's kind of like the Kleenex. When somebody says, hey, can you give me a Kleenex? Well, I have Scotty facial tissue. Is that okay? Well, yeah, you know what I mean. That's where we are with UL. UL is very good at what they do. They're really well known. They're globally known around the world in the industry. And we as manufacturers pretty much gravitate to them because of that. It's very easy for us to get product listed and recognized throughout the world when we have the UL mark. ETL is, again, another very, very good company, but there's different dates. So right now, if I just stick with UL for a second, I as a manufacturer can go to UL and get product listed and to the 7th edition for 268 and 8th edition for 217. And once I do that, I can start to make those new devices under that new edition. But at the same time, until June 30, 2021, I can continue to make older devices, if you will, under the seventh edition of 217 and the 6th edition of 268. And that's what a lot of us manufacturers are doing. You're seeing, well, I'll speak for Johnson Controls. You have two lines running. You have the existing model running for existing applications, quick, easy plug and play, changeovers, what have you. And then I have the newer line running with the 7th edition 268, 8th edition 217 that I need. So I hope that makes a little bit more sense in what's going on. I just checked the time here. Yep, we're getting close to the end. So let me go ahead and I'll pull up here for questions. And Billy, if you want to go ahead and take to the next slide for what you need to do, that's fine as well. And Kathy, if there are any questions, I'd be glad to take them on now, if there's any out there.
Sorry, I had to unmute myself. Thank you, Roger. That was great. I was really amazed at the difference in the flashover times between the older and the newer furniture. But we do have some questions. And the first one is, if detectors go into a control panel and alarms are self-contained, why are the wall-mounted devices that are linked to fire departments called FACP, or Fire Alarm Control Panel?
Okay, so let's talk a little bit. Yeah, so that's a good question, right? So fire alarm control, so today, and again, in our industry, we're trying to use the right terminology for things. Within 72, Nfpa 72, for the last few cycles, some work has transpired to get rid of the term fire alarm control panel and change it to fire alarm control unit. And you say, what's the big deal? Well, there's been a little bit of questioning by the electrical world saying when you call something a panel, that means I have circuit breakers, switch gear, things like that are in it. And you're kind of confusing the industry a little bit. So the fire alarm people stepped back and said, okay, we're FACUs now. So it's fire alarm control unit, but it's also known as fire alarm control panel. So that is a device that sits on the wall in a closet in a basement somewhere that has all of the horns, speakers, strobes connected into it, relays to activate elevator recall, smoke detectors, manual pull stations, duct detectors all tie into that. So sometimes when you're going down a hallway of a building, you might see a sign on the wall that says FACP, and that's just the indicator that's required in building code as to where the fire alarm control unit is located. So I hope that helps out with that question.
Okay, thank you. And now we've got some UL questions too. I hear UL is backlogged on testing the new alarms and being short-staffed due to COVID. Will the enactment date for the new alarms be pushed back to allow more choice?
You know, that's a good question, and that's really a question for Underwriters Laboratory. You know, I really don't know. For us as a company, as Johnson Controls, we have had no problem getting product going through them to get listed, certified, not just the smoke detectors, but other things. But I hope it's not an issue with UL. I am also the current chair of the life safety section for NEMA, National Electrical Manufacturers Association. And we at NEMA work closely with UL on a lot of different issues that they have not approached us with as far as being a concern right now. So I hope it stays that way, but I can't give anything else, no more information on that one.
And this one might be kind of similar. I know you talked about the move-out date being pushed back to June 30th. The person's asking, why was the compliance moved back?
Yeah, so a little bit of inside baseball, right? So the UL standard comes out, and there was a lot of changes that were going on this, right? So all of us, players in the industry, we sat around the table with UL. So it wasn't something that was a surprise to all of us, but changes kept happening throughout the life cycle of this document being modified. So it wasn't like we could send a group of R&D people into a corner and say, here, go make a new product to be approved under this new standard, and they would say, great, but the standard just changed. Now my design needs to change on my new product. So what had to happen was we needed to wait. We needed to wait until UL finalized what it was going to be. The industry agreed on what it was. And then I could go to my R&D guys and say, here's the final document, go forth and make a new product. And that's what we all did. So there was a gap when UL said, yep, we're ready to go, the testing center is ready to go, here's the new standard, we're ready to test product, and we all didn't have product ready. So we needed to go and create product. So we all did that, and we all did that to the middle, towards the end of 2019. The problem occurred, there was a bottleneck, because now we go to UL and we say, hey, UL, I want you to test my device. They're like, great, Simplex, get in line. So, and then the next company, get in line. And then if you make one device, but you make 25 different flavors of that device, on how it operates, well, that's different testing that needs to occur, as well as different document review that needs to occur. So we all kind of saw the writing on the wall that UL wasn't going to be able to get everybody through the process in time. So that the implementation date needed to be extended to allow UL time to be able to test all the manufacturer's products. And again, I'm not saying it is a disparaging thing or anything to UL. They're working as fast as they can before the COVID thing hit, and working with manufacturers. We have a great relationship with them at NEMA and Automatic Fire Alarm Association and the Center for Campus Fire Safety. And it's just where we are today. It's just how things happen. And you can't expect, the entire industry to go through this one entity and get their product tested in time. It just couldn't happen. So that's the inside baseball on how we got to where we are.
Okay. Will meeting the new requirements be accomplished through fire panel algorithms or strictly through detector manufacture?
That's a depends question. That's a really good question. I think and again, I am hypothesizing based on my experience and talking with other manufacturers. It seems like all manufacturers have had to go back to the drawing board and recreate their product or modify their product. And some manufacturers have said that they don't really need to change any of their software to do that, while other manufacturers do require some software changes to make that occur. And again, I don't want to get into product specifics or anything like that, but it really kind of depends. I don't know of anybody who said, here's an upgrade software patch, go put this in your fire alarm control unit, and all of your new devices are compliant with the new UL requirements. Nobody has that, if that's kind of the question. So it takes both. And a lot of cases.
We have two more. One is dealing with apartments that may require low-frequency sounders. What is the industry doing to single-station smoke alarm complying with low-frequency sounders built in?
Yeah, a good question. And so that's a UL 217 product, smoke alarm, and they have a low-frequency component. For those that don't know, real quick update, there has been studies that have been done that have found that the higher frequency that we utilize in smoke alarms in general, at the 3,000, 3,300 hertz, is with some people not able to alert them or wake them up. People that are deaf, hard of hearing, people that are young, people that are old. When we're born, our ears aren't done developing until our teenage years, and the high frequency part isn't done developing until we're in our teenage years. So the higher frequency you just don't hear, which explains to me why my daughters growing up, when they had the old alarm clock going beep, 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 they couldn't hear it. I was like, Rebecca, can you not hear that alarm? Dad, I never heard it. The higher frequency just isn't there. So it was found that if you get down into the lower frequency, the 520 hertz, that had a hockey stick effect on how many people it was able to alert and awaken with that low frequency. So that's where the requirements came into play. So that was put into NFPA 72 and was required on all new systems in January 1st of 2014. And then for smoke alarms, it's been required as well. There are very, very few smoke alarm manufacturers that are out there that I know of that have smoke alarms with low frequency sounders. When you get into apartment complexes, dormitories, things like that, where they're required, what the industry has done, and again, I say this across all of my the competitors, whether you're Siemens, Honeywell, Simplex, Autocall, we all have come up with devices pretty much that have a low frequency sounder built into our smoke detector bases that can accomplish this. So a lot of those have just said, I'm not going to put in a smoke alarm into those units. I'm going to put in a smoke detector marry it with a low frequency sounder base that pretty much everybody has in the marketplace, and then have that, when that device goes off, activate the low frequency sounder, and because it's addressable, when the fire alarm in the building goes off, have it turn on that same low frequency sounder in the room. So yes, I kind of scratch my head why smoke alarm manufacturers haven't done this, but there's an answer for it. So just because the traditional way of doing it isn't available, there are definitely options that are out there. And in some cases, they're probably better than using a smoke alarm that's standalone, because now you just have battery backup maintenance to take place in one fire alarm control unit instead of going into every apartment and changing the batteries or multiple batteries and carrying around all those 9-volt batteries and what have you. So, but you still need to test them and all of that goes with it. But yeah, good question.
Well, and I think I've got another good question for you too. Is there any concern that with the increased price of these alarms that will lead to people not replacing them when they should, and even further lead to increased fatalities?
Yeah, so I don't want to get really into pricing for it. For fire alarm systems, I don't think you're really going to see much of a price increase across the board. For the devices you're going to end up buying at like Home Depot or Lowe's, you're probably going to start to see two different kind of devices here, hopefully sometime soon. One's going to be a regular device that maybe doesn't have a low frequency sounder in it, but in our homes today, pretty much everywhere you go, you're going to need a low frequency sounder. Maybe you don't need one in the basement if it's not a place where people sleep. There's not a couch down there or something. But those are going to cost more money because you need more power. And that's been the whole crux of the matter, is when I put in a low frequency component, for anybody that does anything in the audio world, when you want to have the booming bass or the thump coming from your audio system, you need to have some type of an amplifier with a big speaker, and they always tell you put in that thicker cable wire to get the power that you need to make that happen. The same thing holds true with low frequency sounders. You know, we don't just have a little piezoelectric device that draws very minimal amount of power. The requirement typically now does for low frequency, I need some kind of a speaker, some kind of a little chip amp that can create the tone and play the tone through the speaker, and it just costs more money, and it takes more power to do that. So I hope that it doesn't happen where they cost a whole lot more money and then there's people that choose not to install them, but that's going to be a wait and see thing in the marketplace. And I don't know. It's really interesting to see how this is starting to unfold for those. It's a good question, and I'm not a great answer, but that's kind of where we are.
Well, actually, I got a lot of people came back and said, good presentation and thank you. In wrapping up, there was a question about NISET certification and about PDFs, and I think that's probably something that Billy and I need to get back to those of you that asked that question, and we will by email. And if there's any more questions, I think that probably wraps it up.
All right. Did Billy need to show the last slide?
Yeah, I think. Billy?
Yes, ma'am. I'm pulling up the document as we speak.
Okay. And Roger, thank you again. That was incredible.
That was great. I enjoyed it. Thank you.
And I want to thank everyone for taking time out of their busy schedules, and with everything that's happening with COVID-19, I want to say thank you very much. Roger, thank you so much. Kathy, again, great collaboration, and I just want everybody to be safe and stay healthy. Until next time, have a good afternoon. Bye now.
Thanks everyone. Thanks, Roger. Thanks, Billy.